Welcome to this video, everyone. This is going to be a little bit longer than the other videos because in this one I'm going to demonstrate few of the other kind of scenarios or special scenarios which can happen during this conversion. First of all, we're going to see how do we convert into from primal to dual in case it's a minimization problem. Though I have stated it, but once again just to uh, give you a live demonstration. Then we have these kind of constraints. We have equality constraint here, and also one variable of the primal problem is unrestricted in sign. So how to deal with this problem? So I'm going to demonstrate by solving this problem. So first of all, see, it's a minimization problem, so its standard form should be having all greater than or equal to sign. The standard form should be having all greater than or equal to sign. So if you check, we have less or equal to sign, so that we need to convert by taking the negative both the sides. So the new constraints will be minus 2x1 plus 3x2 and minus x3 greater or equal to minus 5. This is my first constraint. I'll just write it once for demonstration. It's always a very good habit to, you know, write one variable just under the, x1, the coefficient of x1 should be coming to just under the coefficient of x1 here, so that we don't make mistakes while converting. And this one obviously, so we have minus 8x1 plus 4x2 plus 3x3 greater or equal to 8, and the other inequality, that is less or equal to part, if we multiply by minus sign, then we'll be getting 8x1 greater or equal to minus 8. I've deliberately not shown the steps here because I suppose if you don't understand this, just go to one of the previous videos. It will be easy to understand. Now, what to do with this x3 unrestricted in sign? Now, in case of unrestricted in sign, we are going to introduce, or basically we are going to break this variable into two parts. So I'll just write, since x3 is unrestricted, we put x3 is equal to, you can use other notation always, x3 dash minus x3 double dash, where both x3 dash and x3 double dash are greater or equal to 0. So this is how we deal with the problem where the primal problem is having one unrestricted variable. So with this, we just write down the new problem in detail. So the new problem becomes minimize z equal to 3x1 minus 2x2 plus x3 dash minus x3 double dash, subject to minus 2x1 plus 3x2 minus, you can check it, as I have told to arrange the coefficients in such a form that it becomes very easy to take the dual. Then we have plus 4x2 3x3 dash obviously minus 3x3 double dash. And just the negative of this, as we know. And now we have all these variables to be greater or equal to 0. So now we are in a position to convert this to dual. So let us introduce the dual variables w1, w2, w3, w4. So it's a minimization problem, so the dual will be of maximization type. So maximize w is equal to minus 5 w1 plus 9 w2 now rest of this process is same. Now we have subject to, now the first constant corresponding to x1, that will be minus 2 w1 plus 4 w2 minus 8 w3 plus 8 w4. Now it's a maximization problem, so the constraint will be of lesser or equal to form. So this is lesser or equal to 3. Next one, 3 w1 minus 2 w2 plus 4 w3 minus 4 w4 less or equal to the coefficient, that is minus 2. Then we have the constraint corresponding to x3 dash. Then with w2 we don't have anything, so just 3w3 less or equal, let's look at the constraint as 1. Then we have finally w1 plus 3 w3, this is going to be minus for the fourth one, yes, minus plus 3w4 less less or equal to minus 1. Once again we have w1, w2, w3, w4 all are greater or equal to 0. So here also we can you can see that we can take w3 minus w4 as y. Just checking about the third minus, yes. So now let's consider w1 is equal to y1, w2 is equal to y2, and w3 minus w4 to be y3. So now the new problem becomes maximize w is equal to minus 5y1 plus 9y2 plus 8y3. See, as we have taken this, once again we are going to get y3 to be unrestricted in sign. So subject to minus y1 plus 4 y2 minus y 8y3, this are equal to 3. Then we have 3y1 minus 2y2 plus 4y3 to be less or equal to minus 2 minus y1 plus 3y3 less or equal to 1, and we also have y1 minus 3y3 less or equal to minus 1. So in this case we have y1 and y2 are greater or equal to 0, but y3 is unrestricted in sign. We can further, you can see, combine these two now into another form. We can write as maximize w is equal to minus 5y1, which is going to be the final form. And if you don't want to give any negative sign to the right hand side, then we can also do that. So subject to y1 plus 4y2 minus 8y3 less or equal to 3, we have minus 3y1 plus 2y2 minus 4y3 greater or equal to 2, just to get rid of this negative sign. If you want, you can keep it as it is, and these two will be combined to minus y1 plus 3y3 is equal to 1. Then we have y1 y2 greater or equal to 0 with y3 unrestricted. So this is it. Thank you for watching. If you have any kind of doubts, I will also try to send you a set of problems to practice. In case you are having any kind of doubts, we'll discuss it in the class. Thank you.